Okay, so this is the review for the Unit 1 test. I'm going to skip number 2 because they were similar to the previous unit. This is just an addition problem. Our instructions for 3 through 6 were to simplify. So I'm going to just write these out. Sorry. Since it's an addition problem, my parentheses I don't need, and I can actually just combine like terms. So I would get 9x squared from 4 plus 5, 9x squared. 9x plus 2x is 11x, and minus 1. And that would be my simplified answer. The second one, pretty similar, but I'm subtracting everything in the second quantity from the first. So I could also use this as a -1 and distribute my -1. So I have 4x cubed plus 9y minus 6x cubed minus 2y. Make sure that's a minus 2y when you distribute that. Then I combine like terms and I get 4x cubed minus 6. 4 minus 6 is -2, so I have -2x cubed, and 9y minus 2y is a positive 7y. So my answer is -2x cubed plus 7y. The third one, they are both like terms. I just need to simplify. If they're both like terms, then 5x cubed plus 5x cubed gives me 10x cubed. My answer will also have a like term in it. My exponent doesn't increase when I'm adding, because they should all be like terms. So when you multiply, that's when it increases. For number 6, again, I can distribute this -1 to my second set of parentheses, so that gives me 9y cubed plus y minus 1. -1 times -2y squared is a positive 2y squared. -1 times -8y is a positive 8y, and -1 times 7 is -7. Then I can combine my like terms. I only have one y cubed term, which is 9y cubed. I only have one y squared term, which is 2y squared. And then I can find some like terms of my positive y and my positive 8y. So this is like having 1y, so that would give me 9y, because 1 plus 9 is 8. I'm sorry, 1 plus 8 is 9. And -1 minus 7 is a -8. So my final answer has 4 terms in this one. 9y cubed plus 2y squared plus 9y minus 8. Number 7, you're supposed to choose all expressions that are equivalent to the following, even if not factored completely. So here's my expression that I need everything equivalent to. For each of these that has an exponent, that means 2 factors of that term. So I'm going to rewrite this as 3x times 2 factors of 2x minus 1. So 2x minus 1 times 2x minus 1. You can distribute this term out in front first, or you can multiply your base and your height first. I'm going to multiply the base and the height, because if you notice on A, B, and C, they're all pretty similar, except for some of the signs are changed. So we're going to see how that affects our answer. 2x times 2x is a base and a height, so I'm going to multiply them and get 4x squared. -1 times 2x is -2x. 2x times -1 is -2x, and -1 times -1 is positive 1. So if I write all those out, I'm still going to be multiplying at the end by that 3x, so you want to make sure to write that every time you write your equivalent expression. I can combine like terms, and I get 4x squared minus 4x plus 1. Now I can distribute that distribute that 3x through and get 12x cubed minus 12x squared plus 3x. And that is equivalent to my expression above. So the answer to part A is yes. Part B. Again, I'm going to write out my two factors of whatever's inside my parentheses. So in this case, 2x plus 1, 2x plus 1. I'm going to use my area model to solve for my base times my height. So 2x times plus 1 times 2x plus 1. 2x times 2x is 4x squared. 2x times 1 is 2x. 2x times 1 is 2x. And 1 times 1 is 1. I'm going to write all those terms out now. Don't forget, I still have that monomial out in front. I'm going to simplify my like terms, so add like terms together and you get 4x plus 1. Now if you notice, this is very similar to the previous problem, but now I have a plus 4x in the middle instead of a minus 4x, and that's important. If I look at my expression, my middle term is negative. This one worked because my middle term was negative, but if I'm going to multiply 3x times a positive 4x, I'm going to get a positive 12x squared. And this expression is not equivalent because that sign right there is not negative, so that is a no. Part C. I already have two expressions written out, actually 3 terms that I'm multiplying together. So I'm going to use my area model first and multiply the base and the height. So 2x times 2x is 4x squared. 2x times 1 is 2x. 2x times negative 1 is negative 2x. And negative 1 times 1 is negative 1. I'm going to write all these terms out. And don't forget you have that term out in front, that 3x. I'm going to simplify inside by combining like terms. 2x minus 2x equals 0, so I do not have to write it. So this is just 4x squared minus 1. Yeah, I wrote that kind of weird because I want you to see that that equals 0. So I only have to distribute to these two terms, so that gives me 12x cubed minus 3x. 12x cubed minus 3x is not equivalent to 12x cubed minus 12x squared plus 3x, so this answer is no. You can tell because this one only has 2 terms and the other one has 3 terms. And you can't combine like terms if you do not have the same exponent. So, part D, we have a monomial and a trinomial. So I can use my area model to solve this, and it would be a height of 3x and a base of 4x squared minus 4x plus 1. Or you can also just distribute your 3x through. Either way, 3x times 4x squared is going to give me 12x cubed. 3x times negative 4x is negative 12x squared. And 3x times 1 is 3x. It doesn't matter which way you do it, you'll get each area inside here, and that cannot be reduced, so that is the answer, and it does match my expression that I was given, so that is a yes. For my next problem, I have a fraction out in front. You can always multiply by your numerator and divide by your denominator, as long as your fractions go in evenly. Otherwise you have to represent it as a fraction. But since if I multiply by 1, none of these numbers change, but then I divide by 3, since they're all divisible by 3, that makes my job pretty easy. So I'm going to take 36x squared, divide by 3, divide each of these by 3, and I'm only going to deal with my fraction out in front right now, so I'm going to leave that x term out in front. We'll deal with it at the end. So each term I'm going to divide by 3, dealing with my fraction. That gives me 12x squared minus 12x plus 3 on the inside of my parentheses. Then I can distribute my x term, and I'm given 12x cubed minus 12x squared plus 3x, and that is, in fact, equivalent to my first expression. Number 8, I'm going to skip as well because it is also like the last test, so I'm going to move straight on to number 9, but the instructions are still simplified by finding the product. So the product of these, if I have a term squared, I need to write it out and expand it. That is 2 factors of x minus 6. I can use the area model to solve this because it's a base times a height. Here's my base times my height. I get x squared minus 6x plus 36, or positive 36. Gives me x squared minus 6x plus 36. I can combine like terms right here. Negative 6 and negative 6 is negative 12x plus 36. And that is my final answer because I cannot combine any more terms. Number 10, I have 2 factors of 2x minus 3, so I'm going to expand that. Now I have a base and a height, so I can use my area model. 2x minus 3 and 2x minus 3 gives me 4x squared minus 12x minus 6x and a positive 9. So all I'm doing is multiplying my bases times my heights. So 2x times negative 3 will be negative 6 in that case. So I'm going to write all my terms out, showing me where my like terms are at. Okay, negative 12x and negative 6x are my like terms. Those would combine to negative 18x. So I have 4x squared minus 18x plus 9 as my final answer. Next I'm going to multiply x plus 3y times x plus 3y. All I did was expand those out because I have an exponent of 2. Using my area model, I can do x plus 3y, and I get x squared. 3y times x is 3yx, or 3xy. I'm going to write it like that because it's alphabetical order. 3y times x is 3xy as well, and 3y times 3y. Well, 3 times 3 is 9, and y times y gives me y squared. So I got 9y squared. If I write all these out, I have x squared plus 3xy plus 3xy plus 9y squared. That gives me x squared plus 6xy plus 9y squared. And that is my final answer. Make sure you have that squared or you will lose credit. That y needs to be squared. Number 12, I don't need to expand anything out because I don't have an exponent, so I can just put my base up here, my height over here. X times x gives me x squared, 3 times x is 3x, x times negative 1 is negative x, or even negative 1x, and negative 1 times 3 is negative 3. This gives me x squared plus 3x minus 1x minus 3. 3x minus 1x gives me 2x, and I have no other like terms, so that's my final answer, x squared plus 2x minus 3. Number 13, I also have a base and a height, so I'm going to multiply those using my area model. 4x plus 5 and 2x minus 7. 4x times 2x is 8x squared. 5 times 2x is 10x. 4x times negative 27 is negative 28x. And 5 times negative 7 is negative 35. I can write all these terms out just like before. I can also combine my like terms from my diagonal if you would like. 10x minus 28x is a negative 18x. I can show that over here. just to be sure, I'm showing my work. So 8x squared, this is, remember, negative 18x and minus 35. And that is my final answer, 8x squared minus 18x minus 35. Number 14, I have a binomial and a trinomial. That's okay, I can just kind of, my rectangle gets a little bit larger because I have a trinomial, and that will just help me find a couple more areas. So now I have 6 areas that I need to find because I have 2 terms and 3 terms. So 4x squared times 2x is 8x cubed. Remember, when we're multiplying, our exponents can increase. So since I have 2 here and an exponent of 1 over here, I have a total of 3. Negative 27x times 2x is going to be a negative 54x squared. And negative 9 times 2x is negative 18x. In my next row, negative 4x squared is negative 12. Oh, sorry, times 3 is negative 12x squared. For the next one, I have negative 28x times negative 3 is positive, because I'm doing a negative times a negative, positive 81x. And negative 9 times 3 is 27. I can write all these terms out. I will have 6 terms, but like I said before, you can combine like terms here. Negative 54x squared and negative 12x squared, they're both x squared terms, so I can add them together. Negative 12 and negative 54 is going to give me a negative 66, and that's going to be an x squared. So that's going to help me when I simplify over to the side here. And 81x minus 18x is going to give me a 63x. 8x cubed does not have any like terms. I have this negative 66x squared, my positive 63x, and 27 doesn't have any like terms either, so that goes at the end. Almost ran out of room, but that is your final answer. 8x cubed minus 66x squared plus 63x plus 27. Number 15 is also a trinomial and a binomial. You get 3x squared plus 2x minus 4 and 5x minus 1. So I multiply 5x times 3x squared, that gives me 15x cubed. 2x times 5x is 10x squared. Negative 4 times 5x is negative 20x. 3x squared times negative 1 is negative 3x squared. 2x times negative 1 is negative 2x. And negative 4 times negative 1 is positive 4. Combining these like terms, 10x squared minus 3x squared gives me 7x squared. Negative 20 and negative 2, sorry, those are like terms, so that's why I am circling them. That gives me negative 22x. 15x cubed does not have any like terms, so I'm going to write that down. I combined those and I got 7x squared, and I'm combined those, got 22x, and positive 4 has no like terms either, so that just goes at the end. That is my final answer. Number 16 says, write an expression that is equivalent to the following binomials. Hint, factor. I'm going to write down some observations. First of all, there's only 2 terms here, but I do have something squared. I have no middle term, so if I rewrite this as y squared plus a middle term, I have 0y minus 49. No middle term, and that's what my trinomial would look like. So one of my observations, no middle term. And something else is y squared and 49 are both perfect squares. So this was a difference of squares problem that we learned about. So you can use the area model to solve, and you would put your y squared here, your negative 49y here. Because these are areas and I'm factoring, so in order to factor, I'm working from my area back to my base and my height. The only things that I'm going to multiply to get y squared are y times y. To get negative 49, I'm going to get negative 7 and positive 7. And then I can check to make sure that my diagonals add up to 0y. So y times negative 7 is negative 7y. 7 times y is positive 7y. Well, those are opposites, so this does in fact add to 0. So my areas look like this when I'm finished. The other way you can solve this is just to take the square root of each of these numbers. Your answer will be a pair of binomials that look almost identical, because we have the square root of y squared is y, the square root of 49 is 7, so we have y 7, but one of our expressions is going to be y plus 7, the other is going to be y minus 7. That will actually be your answer, and you can see over here why it works, because our middle terms cancel to equal 0. They actually add up to 0. The next one, also the same type of problem. So what I could do is just write these two terms. The square root of 16x squared is 4x. The square root of 25y squared is 5y. You need to make sure you have a y. And then one of them is going to be positive and one of them is negative. If I show that as an area model, I would put my first term in the top left, my second term in the bottom right. 4 times 4 gives me 16, but I need x squared, so I need to do x times x. 5 times 5 gives me 25, but I need y squared, so I need y times y. And then I have negative 25, so 5 times 5, one of these has to be negative. So you can see I have 4x minus 5 and 4x plus 5, because one of them is positive. And that would be your final answer. Number 18 says factor completely. In order to factor completely, the very first thing we need to do is find a GCF. Always. So my first problem, GCF, between 8 and 3, they have no factors in common, but between x cubed and x squared, if I were to rewrite this problem, it'd be like 8 times x times x times x plus 3 times x times x. Well, how many x's do they have in common? They have 2 over here and 3 over here, so they have at least 2 in common. My GCF between 8 and 3 is 1. Between x cubed and x squared is x squared. Okay? You basically want to see what is your lowest amount of variable. So like x squared is my lowest exponent between x squared and x cubed. So that would be my greatest common factor. But that's not your answer. That is just your greatest common factor. In order to find our answer, we're going to take that greatest common factor and put it on the outside. Whatever's left on the inside is what I can divide all of this by x squared, and whatever's left I put in there. So 8x cubed divided by x squared. All I have to do is I took away or took out some of my x's. I'm only left with one x left inside, but my coefficient is still 8 because I didn't divide by any other coefficient. And then I have plus 3, and I have my x squared on the outside already, so I don't have any x's remaining after I pull those to the outside. You could check this answer by distributing. X squared times 8x is 8x cubed. X squared times 3 is 3x squared, and so that is your final answer. The reason we can't factor this more is because I have x to the first power inside here. I can't break that down anymore. I won't have a base and a height because I'll only have 1 power of x. Number 19. Between 10 and 5, my GCF is, between 10 and 15, my GCF is 5, so that's where the 5 came from. And now I look at my variables. How many x's do I have in common? Well, I know I have at least 2 x's in each one, and I have at least 1 y in each one. So that's my greatest common factor. But that goes on the outside of my parentheses, and that's what I pull out of this expression. So 10 divided by 5 will give me 2 left over. X squared is already on the outside, y is already on the outside, so 2 is all by itself. And then negative 15 divided by 5 is negative 3. Well, I took 2 x's out, so that leaves me with 1. I took 1 y out, so that leaves me with 1. So my final answer is 5x squared y times the quantity 2 minus 3xy. Now these are both to the first term, so I don't need to factor that anymore. That is my final answer.